Introducing, we are Group 5. We have title of a project as about Autonomous Vehicle Relational System in Online Transportation, or we can say AVERSOT. And this is our team. Me, Riki Syahputra as project leader, and there's Owen Tan Yik Wen as project manager, and Muhammad Zidan Satrio is also as project manager. On the first slide, we would like to present about introduction on this project. So what is AVERSOT? AVERSOT is the backend system of autonomous vehicles in online transportation, handling the autonomous relational system and an autonomous vehicle system based on SQL database. So what is autonomous vehicle? So autonomous vehicle is a vehicle that works without driver or driverless vehicle. It works with the help of sensor, artificial intelligence, and machine learning. So we handle the text, online transportation, or we can say online taxi. But the taxi is autonomous. So, and the next slide is about how Eversort work. Eversort system is handling data management, processing, and storage of information. In this project, a basis system is used. For the development system, its prospect is for complex and standalone calculation. So what we create and use today is basis system, where there's three relations. It's about input, reaction, and also the result. For the input, it's about destination coordinate, and there's user coordinate, and also unique data for the vehicle and the user. And then the system will go to give a reaction, and give the comment about comment to calculate range, vehicle matching, price calculation, and quality checkup check. And the last is about the result. The system going to give the result is about the G total or check total, total price, and M total, or we can say quality checkup total for every transaction or every order. So besides, the system calculate the total price for the range of kilometer per kilometer, but the system is also calculate the price of the long life system as about machine checkup, but with the autonomous system. And this is the basic system. We also have the development system, but this is like an expectation, or the development is going to that could be created or could be developed for the near future. So what's the difference about the development system and basic system? The difference is about the reaction and also the result. We can say the input is also could be different, but yeah, but what I included here is only the reaction and the result. So for the reaction, where's the difference? The difference is on the first comment. Reaction, it says a comment to calculate range, but in the reaction, in the development, it says the standalone range calculation. What is different about comment to calculate range and standalone range calculation? Comment to calculate range is about status 1 or 0. It's like the comment, but in this development system is about standalone range calculation. It's all about the standalone calculation, or you can say its own formula to calculate the range. And the result is also there's an addition is about there is machine learning, route navigation, performance history, and system comment. And how the environment benefit of this project, or we can say of this vehicle. So the benefit, we take the sample of benefit from the vehicle. Because the vehicle is electric, the vehicle is also has a lot of benefit for the environment, such as go green, because the electric power with the zero carbon emission, it's ensure the sustainability, and then also no pollute with zero carbon emission with no pollution, and also there's efficiency because the system is autonomous technology, so it could minimize the human error. And also the last is save money because the electricity is cheaper than oil fuel. And the next slide is going to present by my team.
Thank you, Riki. Next, we move to entity relational diagram. or ERD. This is our ERD we have created. There are 6 attributes. First is X-user entity, second is vehicle, third is destination, fourth is fee checkup, fifth is fee price, and last is fee transaction. In the first entity, X-user entity, it has 6 attributes. They are end-user, U-long, U-let, U-number, U-date, and in-ID. In the second entity, vehicle entity, it has 6 attributes too. There are V-long, V-let, V-date, V-ID, in-ID, V-type. The relationship between X-user and vehicle is register. Next to the third entity and fourth entity. In destination entity, it has 7 attributes. They are VID, DID, INID, Xrange, DLET, DLong, and DNAME. And in the fee checkup entity, it has 8 attributes. First is CID, VID, CDate, C-motor, C-battery, C-skeleton, C-wheels, and C-interior. The relationship between vehicle entity and destination and fee checkup entity is process. Next to 5 entity, fee price entity, it has 7 attributes. They are PID, M motor, M battery, M wheels, M skeleton, M interior, and air price. And the last entity is fee transaction. It has 7 attributes too. They are PID, TID, NID, TDate, C total, M total, and T price. The relationship between fee price and fee transaction is summarized. Next, we move to database design. Our database design name is AVRS, and the total of table is 6. They are X-user table, vehicle table, destination table, fee checkup table, fee price table, fee transaction table. And the procedure we have in our database is 5. They are add new user procedure, add new vehicle procedure, add new destination, add new fee checkup procedure, and last is add fee transaction procedure.
Okay, thank you very much. Now I will tell you guys about our schematic designs for our SQL. Now in our schematic designs, we have this table right here. We already have the X user, vehicle, fee checkup, destination, fee transaction, and fee price. Each of these strings or liners connect to each other. For example, if you see that some sort of key or light bulb over there, so that is the primary key, and the 2 dots over there, that is the foreign key. So if you can see here, the X user has an NID which connects to the destination's NID as a foreign key, while the X user is the primary key. Same goes to the other table. For example, the VID on vehicle table and V checkup. There's also a foreign key. We have a first design, which is this one, and then we have a second design, which is over here. Is quite horizontal-ish. Anything will do. It's either go up and down or left to right. We don't know exactly which one should we use, so we use both of them. Now next. Oh, sorry. Next is table design and validation. Our table design, well, there are 6 tables, of course. Hold on, okay, there we go. And as you can see, there is, here we have the end user. End user is the name of the user and ID, the name, the user's ID, long, it's basically longitude, latitude, like I don't know, X, Y, Z, some sort of mathematics, just to pinpoint where the locations of the user is, and then date is the date. Every single data type right here is our some sort of function. Like, okay, so let me open up my SQL. As you can see here, we have a varchar, int, float. Those are the functions that we used. Like varchar is to insert our characters. Int is for our integers. Float same as integer, but it's more into putting a bigger number. Begin same as well, but way smaller than float. And then date to tell us the exact date of today. And then over here we have the validation. Same goes with the column. And then of course there will be some, for this one, like not null, which means it doesn't require, I mean, no, it has to be filled. If it's not filled, then we can't really put more data into the bottom part, this one. So everything is not null. And of course NLD will be our primary key. And then for the rest, they are basically the same, I suppose. I mean, there is nothing how to say this? There is nothing really changing for the rest. They all have the same description. Like, for example, a C motor is to check whether or not the user want to check his motor or not, and the ID and validation and column, both are just the same. And of course there will be some primary key and foreign key as well, and it's all related to every single table around it, so it all connects. There is no table that is not connected. That's why we have to make it all connected. If not, that means that table will not exist, because it has no relation. So I mean, well, I guess that's all. And thank you very much. Hope you enjoyed the video, and I'll see you soon. And thanks again for Mira, and thanks again for Zidan and Riki as well. Thank you very much. I'll see you soon.